Good evening, everyone. Welcome everyone to the webinar on microservices versus monoliths, building scalable and maintainable systems. We are glad to have you all here today. I am Grace, your host for today's webinar. On behalf of Kalpita Technologies, I extend a warm welcome to each one of you. So before we begin with the webinar, I'd like to give a quick introduction about Kalpita Technologies and Kamal, our speaker for today's webinar. Kalpata Technologies is an enterprise software development company with 6 years of excellence. We are headquartered in Bangalore, India, and we also have a physical office at Austin, Texas, US. We are a Microsoft Gold partner and SOC 2 certified and recognized as a great place to work since 2021. It gives immense pleasure to introduce today's speaker, Kamal, EVP of Technology at Kalpata Technologies. He has over 20 years of technical expertise in digital transformation with proficiencies in strategic planning, team leadership, financial management, and resource allocation. With further ado, I'll hand over the session to Kamal. Kamal, the floor is yours.
Thanks, Grace. Thanks for the introduction. And let me present my screen and then. Yeah. Let me know once you can start seeing the screen.
Yeah, we are able to see the screen, Kamal.
Yeah, thanks for the confirmation. Okay. Thanks for everyone participating here and who are there. Thanks for taking time and being part of this webinar. This is the agenda what we have for today. We want to touch base upon what is monolithic architecture, what is microservice architecture, want to understand the difference between monolithic and microservice architecture, and then what are the use cases you want it. How do we decide when to use monolithic and when to use microservice architecture? And then want to touch base upon some of the use cases what we have implemented in Kalpita for some of our clients using micro front ends and using the micro architecture at the back end as well. Then from scalability point of view, how do we achieve those things using Azure? And then we'll have a Q&A Q&A session, and then I'll share the references of this webinar as well. Yeah, I think Grace has introduced me, so I'll skip this one. Yeah. So what is monolithic architecture? So monolithic architecture is primarily a traditional way of a three-tier design what we implement in traditional application development, where we have our entire the front end, the middle tier, and the back end all bundled together and getting deployed together. So that's the typical style of monolithic architecture what we have been implementing from maybe last 15, 20 years back. So that's the typical monolithic architecture what we have. In this, right, we have all the components of application, interface, business logic, and data access all tightly integrated and deployed together. Right. Any changes or updates to application requires redeploying the entire code base, though some of the layers or components are not deployed, so not changed. We redeploy them. So that's the typical style of deployment for monolithic architecture. Often, again, it's easy to use because the entire code base is tightly coupled. In the sense, the interactions between the front end, the middle tier, and the back end are all in the same solution of the projects that we work upon. However, over a period of time, as applications grow and the complexity of applications becomes very challenging to maintain them. This is a pictorial representation of a monolithic architecture where you have all your different components or modules tied together talking to a single RDBMS, right? So let's talk about the advantage of what is the advantage of using monolithic architecture, right? So it's very easy to use. When I say easy to use, what I meant by that is this all the different parts of the application, they work together cohesively. So it's easy to build such applications in smaller teams. And your development speed is also fast. The reason for that is you don't need to go to different project solutions and then start debugging or understanding different projects which are outside the system. So your development speed will be much faster. You are deploying all of them together as a cohesive unit. The deployment becomes easy, debugging becomes very easy. And the disadvantage of using monolithic architecture. This is true for what advantage we spoke holds good if the project size is small to medium size. The moment the project size grows big, it becomes very complex to maintain them. And the reason for that is the interactions, the number of integrations between the code or between your layers becomes more and more complex. And let's say that you want to scale a certain section or module in your application. That is not very feasible with the monolithic architecture. You have to really scale the full application. And then the choice of technology stack, what you're going to use, will also be constrained to a specific technology set, because you will not have the flexibility of using multiple technologies within the same code base. Again, as more and more, as the more and more application, the size of application grows, the size of artifacts grows, and then the time it takes to deploy your application also grows. So it becomes tedious for us to do the deployments as the artifact size increases. Again, it becomes a single point of failure. If any of your component breaks, your entire application is broken. So it becomes a single point of failure for us. So those are the disadvantages of monolithic architecture. So let's talk about the microservice architecture. So microservice architecture is typically built as small independent services, each representing a specific business capabilities. So this even if you take the concept of solid principles, even the concept of single responsibility comes to here. Each service is responsible to do certain activities, and that's what even microservice architecture recommends you to do that. And these are very loosely coupled. So what it means is each service communicates to other services, either HTTP or through message queues or broker messaging technologies, but they're loosely coupled and they can be easily extended to build up your features, to scale up or to enhance your product. What we spoke about in the earlier slide is each service is responsible for a single functionality or a feature of the application and can be developed, deployed, and scaled independently. Okay. The microservice architecture has a significant impact on the relationships between applications and the database. So what I meant by that is each microservice has its own data store, and it is responsible to update the database or to connect with its own database. That's what I meant by here. Instead of sharing a single database with other microservices, each microservice has its own database. Okay. Again, it may result sometimes in duplication of data because we want to maintain the integrity between the databases, not really like referential integrities, but to make sure that the identifiers are maintained across the databases. I want to pause for a few minutes here and then talk about if you have any questions before I proceed further.
Kamal, I have a question.
Yeah.
So here, multiple microservices will have multiple databases. I mean, we can't share a single database, right? That's what you are trying to say.
Yes, correct.
But can we overcome that? Let's say, for an example, I have only one database, but is there any possibility, or it's not even possible?
So there is a thing called as hard and fast tool saying these are the recommendations of what typically we suggest to use, especially if your size of your application is very big.
Okay.
I'll give a use case. I think I have one of the use case where I'm talking about where one of our projects, we have a single database, but we have implemented microservice architecture only in the front end, not in the back end. Okay, so again, it depends on the case-to-case basis how you want to use microservice architecture depending on the requirement or use cases what you are addressing right now.
Okay.
There is no hard and fast rule,
correct.
but the recommendation is each microservice will have its own database so that we can scale each component or layer independent of other components. That's the whole thought process.
Hello, sir. Hey, I have a doubt. Like,
Yeah.
should we adapt monolithic first for the main viable product, then scale it up to microservices, or should we launch directly on microservices?
I think, let me put this way. I think if we have a vision of typically the way what I've seen over a period of time in the products what we are building, typically we start with MVP, which means we want to build a very small scalable product. If it is very small, a small MVP, we can get started with monolithic architecture because it's a simple project what you're dealing with. And then over a period of time, these applications gets converted to monolithic as the complexity and the features are getting added over a period of time. And then it's not that once we start with monolithic doesn't mean that it has to stick only to monolithic architecture and can't convert to microservices, right? As the product is getting evolved or the product is getting evolved, you have to make conscious decisions. Okay, I want to take out this particular component or module into on its own layer of service so that I can scale, I can release, and I can develop independent of other features. Again, there are different architectural styles how we want to implement them, but if you have a vision of to start the project saying, okay, these are the things I want to build all of them together. I want to take good amount of time. Again, we can start with again microservice. It depends on how you want to approach the project. So
Like,
both are
which is the
feasible.
best?
Both are
See-
feasible, and that depends on case-to-case basis. If I want to start with a simple MVP, I would recommend to go with a simple monolithic architecture, get started, and then as you see traction and then the feedback on the market, and you see more and more traction on the project what you're building, right? Then the scope of the project increases. We don't want to. I think I want to use a good phrase here, especially with agile world, right? Fail fast. We do not want to spend 1 year of time and then figure out that something is wrong with this product.
But
start small.
But I have just done some Google that like less companies try to scale it for the microservices once the microservices entered the market.
Mhm.
And one of the most successful company which able to do is that Netflix, I think. They
Mhm.
completely switch it to the microservices. Like, what is this case? Like, why all the big governments is cannot able to turn their entire product to microservices?
Uh, I think I can talk about some of the use cases like Netflix, right? If you see the volume of the data and then the features, what they're going to do. The major feature, what if you see from Netflix offering point of view is the streaming, and then the catalog part, and then the search part, right? If you're able to break it down into logical components, and majority of the time you spend time in, again, if you see in the way the user experience is, right, you end up spending around half an hour to 40 minutes to figure out what is the movie you want to watch than actually watching the movie, right?
Like recommendation based.
Yes, the recommendations, the searches, right? You do not, while that is happening, you do not want to really put a stress on your application while someone is streaming your application. So there's a classic example of why you want to use monolithic architecture, microservices there, because there are different sections of users using different features, and both are independent things. Okay. Now, why is that everybody not migrating to microservices? Again, I said, right, if the projects are small enough and they are really not a large scale where you're not really so complex, right? There is no reason why you have to migrate to microservice. There is no hard and fast rule that everything should be in microservice just because it's a good technology. We should look at the use cases where we should. I think I'll touch base upon in the further slides. When should you decide that you have to go to microservices, and when should you can still stick on to a monolithic or street architecture? I'll touch base upon in some of the slides in the future.
See, the main challenge with microservice architecture is integration. So when we have lots of modules, and if we are going to integrate it, so we have, because of loose coupling, it needs more time to integrate and test it. because say one application is not having the compatibility with another application. So in that scenario, it will throw lots of errors and it will be a tiresome. So that is the reason microservices is always recommended for complex projects, because there you can develop independent modules and after that you can integrate and you can plug in and plug out very easily. So that is the reason microservices is required. But if you have a small projects or middle projects, so in that case you don't need separate modules to be created and integrated unnecessarily, which consumes time and resources. So that is the reason both are having their own requirements and expectation. Thank you, Kamal, please.
Yeah.
Okay, I understood.
Yeah. Okay. Let's continue our discussion. Again, this is a pictorial representation of microservices. If you see here, right, each are different layers of services. Each has its own database. And then few things I want to touch base upon is the messaging broker, right? I want to touch base upon that, especially from durability point of view. If one system is down, doesn't mean that my entire workflow is broken. Especially with monolithic architecture, let's say your API is down or one layer is down, your entire application is down. Especially now, let's say that I want to make a post call between one layer to another layer. You can still do API communication, right? I can call the API directly, and then if that is broken down, then we are losing the data. So again, it's easy for us to use a direct API communication. I think the way I would recommend is for get calls, go ahead and use API communication. For post calls, I would recommend to use a message broker, so that if a specific layer is down, at least when it comes back, so that it can pick up the pending messages or whatever posted while it was down, so it can pick up and process them, and then let the downstream processing can continue. So this is something which I want to be really careful, especially with the microservice architecture. One system being down should not result in loss of data in the entire workflows. Any questions, comments around that?
Kamal, this cube.
Yes, Cube.
Yeah. In this approach, when we have microservices, right, especially auditing with multiple databases and multiple services. So how to get a collaborative or a cumulative auditing, because each service will have their own auditing, right?
Yes. So typically what we recommend is we want to consolidate the data of audit logs across the databases into a common stream, and then you can have a common reporting mechanism. Or if you don't even want to consolidate, you can have Power BI reports which can connect to all the different stores and then pull the required data across the data stores and then visualize them together. Eventually, it's one application. That's what we should look at from end user point of view. These are internally layered out into separate services from managing the application in easy way. That's internal to the application. From an end user point of view, single application, and if they want to visualize the audit logs or the reporting mechanism or any aspect of it, right, it should be treated as one. So you have to consolidate the data depending on how you are pulling the data from your systems.
So we'll have a separate database for audit logs from all the database and consolidating into a single data store.
No, you can have audit logs in respect to databases, and then you can have your Power BI report connecting to all the data sources and then present a common view. That's one approach.
Okay. And likewise for reporting. So
yes.
If you want reports
thing, right?
across services.
Yeah. So
likewise, same.
If you want to take example of Power BI reports, right? Power BI report can connect to multiple sources, and then it can collate the data and then present a common view. It's just about communicating different sources. That's it from Power BI point of view.
And one last question: if there is a data between two databases in microservice, so there'll be a sync mechanism, or always keep it isolated. I know in microservice there'll be duplicate data. I do agree, when you architecture it's duplicate data will be there, and that is the style of architecture. But if data should present in both the database, then what is the mechanism?
Typically, right, let's say that there are most of the time we want to maintain the referential integrities, in the sense the IDs we want to maintain between the systems. And then so that using those IDs, you want to pull the data from whichever source you want to there. Ideally, you want to stick to that as long as it is feasible, and then it's not becoming complex to do that. So what I meant by that is, let's say there is a person's data, right? And they want to maintain that in employee database. Any other databases downstream, wherever they're using, you want to have only the employee ID. So whenever you want employee information, you want to make an API call, get called to the respective services and get the data. So that way we have always in one place the data. And we are not really running into sync issues. But it's only the IDs has to be consistently maintained across the databases. Now, let's say for whatever reason, you think it's not feasible for you to do that way, and still you have a duplication of data. And then you want to consistently maintain the integrity of the data between those different sources. So what it means is whenever any source is getting updated, you need to make sure that you need to, once you update on your source, you need to let the respective services know that I've made changes on my end. Please update on your end as well. So you need to make those messages send out to the respective services to update on their end. So that's yes, it will be kind of a sync, but we want to avoid those things as much as we can by maintaining the IDs alone, not the data itself.
Stop it.
Does that answer your question?
Yeah, Kamal.
Okay.
Kamal, Vinuthan here.
Sir, sorry. Can we make use of cache server in case of the two data, like two services need the same data?
We want each service to be independent of another service. We do not want a dependencies again there. If you want to use cache, yes, use cache within the specific database and the service. That should be the context of that usage of it. We do not want, again, if you really want a cache, that should be a service on its own so that other services can consume it. So ideally, that's what we want, the loosely coupling between the services. We do not want, okay, I have cache data, and let's say these two services are dependent on that. We want them to be independent of each other. That's why we're maintaining the separate databases on its own layers.
Oh, yeah. The architecture will be wrong if they
yes.
are.
We do not want tight coupling between the services. That should be loosely coupled.
Yes, yes.
Hello, Kamal, Vinuthan here.
Yeah. Yes, Vinuthan.
Now that each of these services are independent, I mean, they work on their own. Do you think it is recommended to use different tech stacks across each? For example, there may be some like a catalog database, and I may want to use MySQL, which is free MySQL, lightweight. And for highly transactional data, I may want to use SQL. So is it recommended to use different DB stacks across different services?
That's the advantage of microservice architecture. Yes, I think I'm going to touch base upon that. Yes, if you think there is a use case of specific layer service wants to use a different technology stack and you get advantage with that, yes, it is recommended to do that. And we can do that.
Okay.
That advantage of microservice architecture is the flexibility in the architecture or the technology between the services. One layer can be in .NET, another layer can be in maybe Java and can use a MongoDB or NoSQL-DB. Yes, it is feasible and we can do that.
Okay. And how does authentication across all these different databases that we have, how do you integrate that?
Most of, if you see, right, eventually the authentication is happening at, let's say that let's say typical website, right, what you have an authentication form. So you authenticate yourself there. So once you authenticate, token is generated. That token or your service is able to authenticate it. It's all about exchanging the tokens between the services. Even if you want to communicate between one layer to another layer, it's all about the token, what is going to generate and share in your payload, and the respective service is going to authenticate it. It's all about token exchange.
Okay. Thank you.
JWT like that.
Sorry, someone was saying something. Yeah, it could be JWT or yeah. Mostly I think these days it's all JWT token. And then we can even, again, I'll talk some of the use cases, what I'm talking. We can even have out-of-the-box solutions these days with Azure AD B2Cs. Azure AD B2C can generate a token. And then again, that's itself is JWT token. And then we can start exchanging that token across services. Okay.
Yes, sir.
So yeah. So I just wanted to emphasize on this message broker. The reason is we do not want to lose the data when any layer or service is down. When it's up, it should be able to go and pick up the pending messages and process them so that the downstream process can continue. So that's very important with microservice architecture, okay, from a design point of view. So yeah, some of the flexibilities I want to talk about is scalability. What we spoke about is I can extend or I can scale the application specific service independent of other services. I can do that. We get the flexibility of using technologies. So one layer can be working on a specific technology, and even the backend could be a different one. Another layer or a service could be using completely different technologies. So that's the advantage we get with this architecture. When I say resilience here, this is primarily about, that's what I was talking about the service broker, right? Yes, just because a specific service is down, entire system is not down. It's just that a specific feature or component is down for some time. Once that is up, it will continue its processing and it will continue as it was supposed to do. So that, again, unless you make the right architecture decisions, this will not happen out of the box. This has to be done and designed properly. And when I say agility here, I'm primarily referring to in terms of developing independently and faster development, right? Each service could be developed by independent teams without really, without really knowing the full architecture, the full understand the full complexities of projects. All we are trying to do is, as long as we maintain the contracts between the services and as long as they respond to those contracts, this can be developed and deployed independently. Okay. Easier maintenance is like, that is I'm saying that is we can update them, maintain them independently, which means different teams could be responsible to maintain specific services. We don't need a simple or one big team to maintain the full application. So we can have pockets of teams doing a specific responsibility. Technology diversity, this is something we covered earlier. Again, we are talking about advantages. At the same time, I think we want to talk about disadvantages as well with microservices. They become complex. When I say complex, now we have different teams doing different things, and then you have to coordinate between them, and then can result in a more complex deployment and monitoring environments. So your deployments could become complex. So with monolithic architecture, you have a simple single artifact that has to be deployed. Now, let's say there are 5 different microservices. You have to have a different deployment cycle for each of them, and you have to make sure everything is getting done correctly. Increase overhead. What I meant by that is, here now, let's take a case of monolithic architecture, right? From your middle tier to the back end, it's all happening in the same API call. We are not really transmitting the data over the network between the services. So that becomes an overhead for us now, which means you're exchanging the same set of data between multiple layers to do a specific operation. So that becomes an increased overhead that may add to your time delays, but that has to be factored in and designed accordingly. Deployment complexity. Now, each service could have its own deployment cycles, and you have to monitor all of them separately and independently. Monitoring and debugging. This is something which I wanted to emphasize a little bit. With monolithic architecture, it's easy for you to debug a specific issue, because you know once you enter, there's only one entry point and one exit point to a specific use case. But with microservice architecture, the entry point could be one, but from there you could have multiple entry points to other services. So you need to start understanding or tracking all those flows so that you understand where the problem lies. So debugging or understanding the root cause of the problem could become challenging and complex because of the communication, integration between different services. Okay, any questions around this? Because this is something, especially, these are the practical problems of what we'll run into once you start developing complex solutions and then start maintaining them.
I have a doubt, sir. For the monolithic architecture, we do the testing part, right? So this microservices architecture.
Sir, your voice is breaking for me. Can you repeat that?
Sir, I was saying we do a test for our logics, right? Like for the
Yes.
monolith, for microservices, is there any different way of testing? Like we have many databases and codes also will be different.
So I think you should look at the same way of testing it as well, because each service is eventually should be bound and tied to the contracts what they're exposing. As long as you adhere to those contracts, you should treat them each service independent, and it should be tested the way you test your regular applications. I don't think you should really change the strategy how you test your applications. It's just that the testing should be done independent of other layers of services.
Okay, just mocking every services and we do the
Yeah,
test.
every service should be mocked and tested thoroughly, and you should do your code coverage across every service. Only thing is you may end up having different teams doing different things. It's just that one team may not do everything.
Yes.
Okay, and
Kamal,
then the cost.
on high
Yes,
availability, so each service will have multiple database. So each database will become two, one for read, one for write, if you're doing high availability.
Yes. I'll touch base upon that. Yes, if you're really looking at high availability of every layer, and then every database, yes, every database will have its own read copies and write copies.
And
that's when the cost will become more.
Yeah, and you talk about technology agnostic. I'm really concerned. Middle tier, I'm like kind of what you recommend. It's nice, but on the front end, if one service is Angular, other service is React, then how the context switching will happen? How you are transferring data between? I'm telling about the front end.
Okay. Sure.
Middle
So,
tier, I think that's the right
eventually,
approach.
Either these technologies of either Angular or React, eventually they're all for to more of abstraction on top of your HTML and JavaScript. Any of these frameworks, what we talk about. When it comes to the client-side browsing and client-side rendering, it's all about once you compile your solution and then emit your artifacts, it's all about HTML and JavaScript. This, if you take under the hood of Angular or React, once you compile your solution and then which you actually deploy, they're all transformed or they're all transformed to HTML and JavaScript. So eventually you are dealing with JavaScript and HTML codes once the code is deployed. So the context switching is will not be a challenge. The reason is each will work independently. I think I'll touch base upon in some of the demos or some of the use cases which I'm going to talk about. Yes, we can still do the same thing. We can still have one particular micro front end in Angular, another particular front end in React. We can still achieve that.
Then Kamal. Okay, got it. Thank you.
Hi Kamal, this side Chetan.
Yes, Chetan.
So except this, like in addition to these advantages, disadvantages, what about versioning when we want to do versioning in the microservice architecture? Like we want to do merging of APIs or something like that. We do easily in monolithic, but what about microservices?
It's the same thing, right? I don't think the concepts of versioning will change between monolithic and microservices, because each service, as long as they ensure their backward compatibility and as long as it is communicated how long they support the backward compatibility, it is still achievable. Because each service is independent of other service. As long as those endpoints are maintained and then the backward compatibility is maintained, you can still achieve the same thing. I think the concept of versioning does not change between monolithic and microservice architecture. Still, it's a service.
Okay.
It's just that we are treating them as independent services.
Okay.
Hi, Kamal, Sunil here.
Yes,
Kamal, which is the most usable, API across microservices, and why we are using that API, and is there any alternate for that in the software?
Following the question, Sunil. You see API, what does that mean?
API, we are using some APIs, right, in the microservices for communication, right?
No, I think, let me put it. We are not using any APIs for communication. We use HTTP protocol or message brokers for communication. That's where we said. are loosely coupled and communicate with each other over a network, often using lightweight protocol HTTP or message queues. These are the communication protocols. That's it.
Okay. Got it. Got it. Okay. Thank you. Yeah.
Okay. Okay. Any other questions before I look at
Hello?
comparing them? Yeah.
Kamal, when there is monitoring challenges, how we will overcome the security challenges?
Can you repeat the question?
Yeah, there is monitoring complexities and disadvantages related to monitoring, right? So how we will overcome the security challenges?
Monitoring is different, security is different. So monitoring is what we are saying is that because there are too many services, and then each service audit logs or anything, right, they're getting tracked at the service layer. Now, but eventually, if you see holistically, that's a single application for us. So we need to track them independently, though they are getting tracked independently at every layer, but from reporting point of view, you are still reporting holistically across the modules from end user point of view. That is the monitoring part. Security, I think we touched base upon saying eventually it's all about exchanging the right tokens between the services, and then as long as they're getting validated correctly, you have your authorization mechanism done. So I'm not sure what is security challenges you're referring to here.
So when like flows, if we are not monitoring properly, only like we will feel like some security challenges, right? Like flow controls, if we are not monitoring properly means.
See,
We can implement multiple scanning tool as well, okay, as a whole. See, each and every module will be tested thoroughly. Only challenge is integration. So when all the modules are ready and when we integrate it, during integration testing, whatever challenges comes in, that we have to take care. So that is the main challenge in microservices architecture. Now coming to security, so multiple security tools are there, and based on nature of project, you can choose some security tool, whether it is for a scanning tool, SAST or DAST. So based on that, you can choose and you can implement it. So that security tool will be implemented at module level and one as a whole, means for complete architecture.
are you referring to security risks or the you're referring to security risk? Yes, because the number of entry points to applications will become more. You have to make sure every service is protected and secured correctly. So if you're referring to that, yes, the number of entry points to application will.
Yes, yeah, that is the
that is
concern.
correct.
Yes.
Okay, so yes, that has to be taken care because that comes as a part of your loosely coupling architecture. So we are going to make sure that the way you do your monolithic architecture, the only change that will happen here is instead of monitoring a single service, you're going to monitor multiple services. That's the complexity. That's the disadvantage what you're running into. Monitoring.
Yes. Yes. Okay.
Okay. And then the cost part, right? The same thing. The cost, as because you're going to create the number of databases more, and then the number of replicas more for redundancies, you're going to create them more. So there'll be a cost, but there is an advantage as well by doing that to make sure that your application is highly available and scalable. Again, you have to do a fine balance between that. I think I'll talk about that, especially how do you do those things with Azure infrastructure and still control the cost as well around that. When testing becomes a little bit complex because you have to make sure that you test every service layer. It's not just that you test your one endpoint and then you are done. You have to make sure that your entire flow across the services and layers is done, taken care. And this not applies only to functional testing, but your security testing and all the stuff, right? All of them has to be repeated to every service layer. That's a disadvantage you run into. But that's a trade-off, right? That's a trade-off you get in terms of getting the scalability and the flexibility of building and running your applications. Okay, let me move on. I know we have 20 more minutes. Let's talk about the differences between, again, something we are just summarizing what we spoke, the single tier architecture and multi-tier architecture, and then the artifacts. I mean, it's a size, right? Based on reference artifacts here. They're all large, all components tightly coupled. You have a small, loosely coupled component, so which means I can make changes to a specific component, release only that component instead of fully packaging everything and deploying it together. In deployment, we deploy a single unit here in the monolithic, and then you can deploy them independently. Yeah, this is something we want to touch base upon. Horizontal scaling, right? If I want to scale a specific, especially monolithic, I have really scaled full. I've scaled everything, or entire artifacts or entire service has to be scaled. But with microservice architecture, if I have 5 services, I can scale only one service because that's the only service that is getting more traction or more load is coming into my application. So I can scale only that, and then I can save cost. Instead of making 5 copies of full application, I can make maybe 5 copies of a specific module. So the cost can be controlled. Again, development is it'll be simpler to start with, but again, it becomes complex as the product grows with monolithic. Microservices, yes, it could be complex with multiple services. Technology, I think we touch base upon limited technology choices, and then you have multiple choices depending on the use cases what you are addressing in a specific service layer. Fault tolerance, entire application may fail if a specific component or module is failing within the monolithic. At least here you can make sure that full application is not failing, only a specific module is failing, and even we can build, we can design such a way that as soon as it comes up, you can pick up the rest of those processing and continue the work there. Easy to maintain, more effort to manage multiple services, less flexible as all components are tightly coupled, again more flexible as components can be developed, deployed, and scaled independently. Yeah. So here the network overhead will be less. With communication, you have more network overhead because you exchange data between all the services. Yeah, some of the use cases which you can think of when to use monolithic, when to use microservices. I want to pause for a few seconds so that have a look at them. Any questions, we can talk about them here. Small, simple applications, you want to use monolithic. You're a small team, not really a big team, you can use monolithic. Low operational complexity, frequent changes are not expected, you can use monolithic. You want really a fast development and iterative and independent deployments, high scalable default isolation needed, different technologies evolving. You are reacting to the product and then making those changes. You can start using microservices. Any specific questions you have before I move on to use cases? Okay. Yeah, I have 2 use cases which I'm going to touch base upon. One, how did we apply microservices using micro frontends, which means applying microservices on the front end only, but not in the backend. So backend, if you see here, there's only one single API. It has one SQL Pass database and cache, but there are multiple micro frontends. So there's a single host which is loading the artifacts of these respective microservices. Now, I think something we're talking about, right? So this specific microservice, MF1, whatever you're talking here, right? Micro front end, it could be built in Angular. This could be built maybe React. Eventually, this produce artifacts of HTML.js. So I'm going to refer those artifacts inside this host. So depending on the route, I can route the request of appropriate micro front ends. That is still feasible. Okay. Now, again, we are building micro front ends, so which means before even I get on to jump on solution, right? Let's talk about the use case what we are trying to address here. Right? Again, this is built for one of our clients. It's primarily used for data collection for insurance products, right? Each insurance product has a different set of UI fields to capture depending on the product that are getting sold. Okay, and then the data is getting stored in the common form as JSON data in the backend, so that respective reports can pull the data and then visualize the data what user is submitting. So the API layer is a common layer, which it's a consistent way of storing the data. All we are doing is whatever data it's getting, or getting submitted from the respective micro frontends is serialized as a JSON and getting stored in a consistent way in the database in the backend. But if you see here, now we have the scalability of using different technologies. One is that, and then I can have each product developed and deployed independently and can be released independently. And even the testing time here will be less here, because in a typical monolithic architecture, if you think, if I have, let's say, 5 different products getting bundled into one, every time I do testing a full application. Now with this, if I'm doing any changes to the specific micro front end, I will develop and deploy only this, and I can test only this specific micro front end. So even you can avoid the amount of testing time as well here. Any questions, guys, here? Okay. Let me move on. This is another use case which you are talking about here, where we are using microservices in the backend. Okay. Again, here we are using Azure AD B2C for authentication purpose. So the token is getting generated at the AD from the Microsoft point of view, generating a token, and then this token is getting shared between the microservices. So I have 2 microservices here. This is one microservice, it has its own database. Again, it's using, again, a lot of things were removed from architecture point of view because we don't want to expose too many things from design point of view. We want to keep it simple. We have one more microservice here. It has its own past database. So each of these, if you see this service API is one, and then you have one SQL database. I have one API and I have one SQL database here. Each of them can scale independent of each other. We can do development and deployment independently. But the front end, the Angular application here is talking to this application, and this application is talking internally to another. So even from the communication point of view, Angular is talking to only one application. It's not really talking to this application. So both are, it's even hidden from this front end part. Only this is exposed to the outside world, and this can scale independently. The reason why we have done is this specific API service is getting used in a lot of other applications as well. So we want to keep it isolated and scalable at the same time. Okay. Any questions around this, guys? Before I move on to the last topic for this webinar.
Kamal, actually, I have a question. Like in that micro front-end architecture, right? We are just having only one API which will handle all the requests. And here,
Correct.
like in this microservices architecture, we'll have microservices architecture, but from the front-end point of view, only one API we are going to communicate. But my question is going to be, is it a good idea or bad idea to have micro front ends with different microservices architecture? Let's say, for an example, instead of calling one app, instead of communicating with one server, can we communicate with different microservices from the front end itself? Is it a good idea or bad idea?
Again, I want to understand the use case, what we are trying to solve and what is that we are trying to address, right?
Yeah.
It all depends on the use case. There's nothing called as, yes, if the use case demands for us to be able, each micro front end to be able to talk to its own API, yes, if the use case demands that.
Okay.
Right? Because if you see here, right, again, the use case what we are addressing here is we did not want to change the way we are storing the data. It's a consistent way of storing. And then the API is scalable enough for us to be able to do that. And then that's why we do that. The bottleneck was around the front end part because the UI is changing, but not the back end part. That's where we have done the micro front ends here.
Okay.
Okay. Now in this use case, other use case, right, where the specific service is independent of everything. It's just that this service is using this other microservice. So this service could be consumed by some other applications that are outside this boundary as well, because this is independent API service. It has its own database and its own functionality. I want to emphasize one thing here, guys, especially in the microservice architecture, right? The responsibilities, one of the core principles of solid principles, right? Single responsibility. We want to make sure each service is doing a specific defined responsibility and addressing the specific use case. Right, that's where you want to be very cautious. And just because we want to do that, we not want to over engineering and then create for every small functionality of one microservice. Right? We not want to do that again. We should take a balanced approach and then make sure that we separate the responsibilities between the layers so that they can scale independently, and then it's easy to operate that way.
Got it. Okay.
Okay. All right. One last thing which I want to touch base upon, then we move on to Q&A questions, is how do we achieve the scalability using Azure PaaS, right? Especially with the context of microservices. This I want to touch base upon app services, containers, and the SQL Elastic pools. App services typically, if you go to app service, right, this is used to deploy your code, and then you can define rule-based scaling mechanism. I can say that if my usage of the application or my memory or the number of requests are hitting this limit, I can increase the number of nodes of my application. I can do this auto scaling, auto scale down. It's not a manual one. We do not want to over allocate the resource and underutilize them. At the same time, right, under allocate and then become bottlenecks. So we can achieve that scalability, dynamic scalability, depending on the usage of them. We can achieve that using app services. When you say app service, primarily your middle type code or your front end code. Containers, right? Again, containers, you can use Dockers, and then the Kubernetes clusters and all the stuff will come into picture, the pods and all the stuff. You can scale them independently each other. And this is a very classic example of microservices, where each service could be a pod, and then you can scale them independently. Okay. Then I want to even touch base upon the database, right? How do you scale your databases? I do not want to really over allocate and then have too many read-only copies, right? There are two things for what you're talking here. One is the high availability. When you say high availability, we want failovers. So which means if the primary node is failing, I want the second node to come up. Other aspect is within the service or a server, if my usage is increasing, if I keep on increasing the number of nodes in the front end, is my database capable enough to handle that load? If you're not scaling your database, whatever you do in the front end doesn't make any sense, right? It will be a bottleneck in the back end. So how do you achieve that? Okay, we have a concept called a SQL Elastic pools. So what it means is you can have a shared databases, and then you can allocate certain amount of resources there. It doesn't mean that I have to allocate all of them to start with, right? I can have a certain section of resources assigned, so that depending on the usage, if I see that okay, this specific I have 5 databases and I have, let's say, 30 GB RAM allocated for this specific configuration. Out of that, 4 databases are really low. Only one database is spiking up because of whatever demand, right? I can make sure that this database alone is consuming the additional resources available in that configuration or the pool. So that you can achieve using SQL Elastic pools. So which means I'm able to scale the compute resources and also the memory resources within a constrained set of resources. Again, we not want to keep on scaling the to X limit so that the cost becomes uncontrollable. With this, there are two things we are achieving here. One, I know the maximum cost at any given point of time. Right? It will not go beyond that, because the only thing is I'm allocating. It's like each database I know optimal usage. I know this much I can use are required for each database, but at the same time, for additional load, if at all it comes at any point of time, I can use the available resources. So once it comes down, I can release them. The other database can use that. So that's the concept of SQL Elastic pools, guys. Just scaling only the middle type doesn't help us in the overall solutioning point of view. You need to make sure that all your layers and tiers are getting scaled so that your entire load is getting addressed. Okay. Any questions around this? And we have 5 more minutes. Okay, I want to bring it on to the Q&A questions, Q&A section here. Anything now, in general, to all the things what you spoke about.
So Kamal, we have a question from Prajwal.
Mhm.
So the question is, we store tokens in the context and it is used wherever and whenever we need. But if the token is stolen from the cookies where it is stored, how can we make sure no one will outrun this token?
Can you repeat the question so that I understand it correctly?
Yeah, we store
It's
tokens in the
it's written in chat, Kamal.
Okay, let me see that. Chat. Okay. We store tokens in the context and it is used wherever and whenever we need. But if the token is stolen from the cookies where it is stored, how can we make sure no one will outrun this token? Okay. Okay, let me talk about this. Ideal way, I know, like we can store tokens in a cookie. And typically, if it is HTTPS transport protocol, right, stealing any data either in cookies or your local storage, it's very challenging. Okay, so what you could do is, right, you within your cookies or tokens, you can even have from which IP you are originating from. You can have your restrictions around that, and then you can add those validations into your the way you validate your cookie, right? The validity where every cookie has expiry. Along with expiry, you can make sure that to whom you have issued this cookie or a token, and then you can check whether the token is coming from the same request or not. That is one way of looking at it. Ideally, with the way we are operating with our is we don't typically use cookies. We use the local storage, especially in the browser. It's as good as your cookies. But only thing is these tokens have a validity expiry, and they're all HTTPS protocol, which means it's. I don't think you can really steal the information from HTTPS protocol. If yes, even still you are able to do that, still you can check from which source. Basically, you have to apply your cost principle here. Is the request really coming from the same domain? Though you get a token, I don't think if a request someone else is making an API call to you from another domain, you should honor the request. You should still throw it as unauthorized. Does it answer your question, Prajwal? I think it should be the
Yes.
combination of your costs and also your token validation.
Yes, sir. Like typically, like a token will upgrade for certain period of time.
Sorry, I did not get that.
I got that. For example, we have a service where authorization is only for 30 minutes. Let's consider it's a social app, and after 30 minutes, he will again he will ask to like he will be prompted to authorize again. At that time, we can see like whether the user is authorized or not.
Yeah, one is that, and also you should have concept of refresh tokens. So which means your token is getting expired, you should request for a new token, and then the new token should be issued from your source, and then you can get the token. Along with the token, don't open it up for everyone to make an API call and then get the data. You should have a restriction on the costs. Which domain can make, what are the authorized domains you can get the calls, though it's a valid token. So both are important, Visual.
Okay, sir. I got it.
Okay. What else?
Yes,
Okay, we have 2 more minutes. Anything else you want to touch base upon or talk upon?
If anyone has any questions, you can unmute yourself and ask.
Sir, there you mentioned there was a message broker, right? Like, what are the services? For example, we have a Kafka. Like, what other we have message brokers?
You can use any messaging broker technology that you have something in Azure, you have RabbitMQ, you have Kafka. Any messaging broker works fine. Okay, I want to wind up this. I know we are coming close to our webinar. Our time is running out. So again, thanks for your time, everyone who has attended and then making this interactive and everyone participating in this discussion. Thanks for your time, and then see you soon.
Thank you so much, Kamal. It was
Thank
really
you
very
so
nice.
much.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you so
Kamal.
much, Kamal,
Thank you.
for the insightful sections, and thanks to everyone who participated.
Thanks, guys.
Thank you, Kamal. Thank you, team.